Hi everyone. In this video we'll talk about sampling techniques, a little bit about data collection. This is just a really brief introduction. So if you want to go in more depth, you may have to look somewhere else. But this hopefully will give you the vocab and the ideas you need to look at those more difficult sources. All right, let's get into it. Data collection. Basically, when you're wanting to get some data to do some statistics on, you can get that a number of ways. You could analyze records, you could make direct observations, you could do an experiment, or you could take a survey, whether that be in the form of a written questionnaire or a personal interview, or variations of those using different technology. Okay, so you've got this data, but whatever method used to collect the data, you'll have to address the issue of sampling. That is, how do you choose your sample so it's unbiased, so it gives you a genuine explanation of what's going on, and it's fully representative of the whole population. Okay, that your sample, you can make conclusions on your whole population based on your sample. All right, we're going to look at the 4 basic methods statisticians use to do this. Before we get there, what is this sampling business I'm talking about? Well, basically, you've got your whole population. There's our population of 100 people, and I want to take a sample of 10 people, and I can say whatever the data tells me about those 10 people, I can extrapolate back to say that is potentially true of the whole population. However, we've got to think about how we choose the sample so that it is unbiased and representative. There are 4 major methods that statisticians use, and I'll go through them with you now. There are a bunch of other methods that are also used, and I'll mention them at the end just really quickly. What I'll do for each of these 4 is give you a definition, I'll illustrate it graphically, and then I'll illustrate with the example of our school getting a new uniform. And we want to survey students' opinions about it. How will I choose my sample of students? Okay, so here we go. First is random sample. The main idea with random sample is that each member of the population has an equal chance of being selected. How do you assure this? Well, these days mostly we use a random number generator, or you could just draw names from a hat. So basically, if this is our whole population, what I could do is, here I've used my random number generator, just using Excel, and I've selected those 10 people as my sample. See, it doesn't have to be really high tech or elegant to do this. Just use simple command on Microsoft Excel. So 45, that's this guy. 52, that's this guy. 30, 79, etc. So that's how I select my 10 people. If I'm doing the school example, what do? I give every student a number, and I use a random number generator to select the sample. Okay, systematic sampling is where you use a pattern to do it. You order the elements or order the people, and then you take every kth element. So every however many number element. Here's an example here. That's my sample. I took every 10th person. So again, in my school example, I'm going to give every student a number. Actually, they've already got numbers. They've got student numbers. I put the student numbers in order. I pick every 10th student, or every 7th student, or every 25th student, whatever. Right? However many people I need in my sample. Okay, stratified sampling is where you divide the population into subgroups called strata, right? Just like strata in the earth or strata in the stratosphere, atmosphere. according to similar characteristics, or probably the word homogeneous is a better description here. Then you take a sample from each group. It's hard to illustrate in my diagram here, but basically I could choose all of those people. Basically, this example might explain it better. In our school, we want to get the students' opinions. I choose 3 students from each grade, right? Each grade is a strata of stratum, okay? There are different strata, different groups, different homogeneous groups. And if I randomly choose a certain number of students from each strata, I got a random sample. Okay, the next type is cluster sampling, and this is where you use a pre-existing or natural group. So my cluster might be the people who are all located around here. In our school example, I might choose all the students who have their homeroom in my room, or all the students who play in the band, or all the students who take geography, okay? Something that naturally groups them together is a good way to do that. The potential problem here is there might be a bit of bias when all the students are clustered in this pre-existing group. Okay, so that's the 4 types of sampling. Now you might also hear this word sampling error and non-sampling error. This is a little bit complicated, and this is just a super brief introduction here. So basically, sampling error is the difference between reality and what your sample says, okay? The difference between the results of the sample and the results if you took the whole population. Okay, now this isn't really an error the way we might normally think of the word error. It's not a mistake. It's just the fact of reality that our sample and the whole population are not going to be exactly the same. It's never truly representative. So there is ways of predicting for this and accounting for this, and that's a whole area of statistics that's really interesting but quite complicated, so I'm not going to get into it here. But that's sampling error, all right? Difference between your sample results and the overall real results of the whole population. Non-sampling error is not the opposite. It's just something slightly different. It's an error made during the data collection process. Okay, so this is a mistake, all right? Sampling error is not necessarily a mistake, it's just a fact of reality, or the way the world is. Non-sampling error is when you make a mistake, okay? This might be because you made an error in collecting the results. Maybe your survey was bad, maybe you asked a unclear question or a biased question. Maybe there was a problem with your equipment, maybe you had scales that weren't tared properly, or you rounded incorrectly, or you used one person measured in inches, the other measured in centimeters, and then converted. So yeah, crazy things like that. Also processing errors. Again, this could be a rounding error, or you use the wrong formula or something like that, okay? So that's sampling error and non-sampling error. Sampling error has to do with a fact of reality. Non-sampling is a mistake. So that's it. So basically, here's a little summary. Random sampling, that's done by random chance. Systematic sampling, when you take every nth person. Stratified sampling, when you group them according to their similar groupings. Or cluster samplings, you use a specified pre-existing group. Maybe people who are in the same location or same, location's probably the best explanation. just really quickly, I'll run through these 6. Convenience sampling, you just ask the first people you see. Not a good way of doing it. Quota sampling, where you have quotas you've got to fulfill, half men, half women, or 5 people from each ethnic group, or whatever. You've got to fill a specific quota. Snowball sampling, where you ask one person and he recommends the next person, then he or she recommends the next person, or determines the next person, right? Sequential sampling, this is used in quality control. When you take a sample, we're not just taking a random sample one at a time. You kind of take a random sample and then you take the next 3 or the next 5 as well. So you sample small groups, sequential sampling. Double sampling, when you take a sample of a sample. Okay, based on the results of your first analysis, you sample again. Multiple stage sampling is basically when you use a combination of the first things up here. So you use a cluster of a strata and then randomize, or you use a strata of a cluster and then randomize. Okay, that was super fast, super quick, super superficial probably. So if you want to go deeper, please do, but hopefully this gives you the tools with which you can go deeper. Good luck with your further studies of statistics, everybody.